Hello, Java Challenger. We are here today in another weekly live. So this live happens every Tuesday at 10 p.m. London time. And congratulations for you who are here to improving your career. And today we're going to be talking about the engineering mindset, how top Java developers think and solve problems. Just some context about this topic because it's very important. So I used to think I was a Java developer, right? And this mindset is not that good because if you think you are only a Java developer, your skills are very restricted. I had a very embarrassing situation in one of my previous jobs where we were in a kind of introduction meeting and everyone was saying, I'm a software engineer, and I'm a software engineer. And then it was only me who said, I'm a Java developer. And then I noticed how restricted it wasn't that strong, my mindset that time. And I noticed how much more powerful is the mindset of a software engineer because really nowadays, companies, obviously they like that we know a lot about Java, but they prefer someone who will solve the problems, right? And this is even more true with the microservices because, when you're working for companies with microservices, if you know Java, that's great, but it's not the thing that will really make you more impactful as a Java developer or as a software engineer. So we need to learn here some principles that will make you a more prepared software engineer, someone who is in high demand for the market because like a programmer is not in high demand for the market anymore. Even more nowadays with AI, because with AI, we can generate the code we want. And like remembering your syntax of programming language doesn't really matter too much, right? What really matters is your ability to solve problems. And the really important thing is to master fundamentals, because if you focus on mastering tools, you're going to become a programmer, and that's not what the market wants. So just to give you some context that the programmer mindset is obsolete. And if you still have this programmer mindset, you're going to lose in the market. So nowadays, developers who are capable of solving problems, general problems, they're more valuable because nowadays the backend developer area is huge because we have the backend, we have security, we have algorithms, we have all the microservices technologies such as containers, Docker, Kubernetes, we have AWS, we have Jenkins, we have so many tools in the backend nowadays that if we even try to master all of those tools, you're going to lose as well. So it's better to master fundamentals. So let's start exploring some of those topics that makes us software engineers. So the first one is to basically be a good problem solver. So one way to improve your problem solving techniques, your problem solving skills, is to solve those annoying LeetCode and HackerRank exercises. I know it sucks to solve those code challenges, but it makes you a better software engineer. Why? Because for each programming challenge, you have to read and understand the context of the problem. Then you have to take some notes, and then you have to write a solution in code to solve this problem. So algorithmic thinking really helps you to solve a day-to-day job problem. And sometimes it even helps you to learn more features from the Java programming language, such as collections, streams, or the wrappers. Anyway, this is not the important thing because the important thing is really how you can solve the problem. But if you're using Java to solve those algorithms problems, it's going to definitely help you to solve those problems more easily. And guys, if you can turn on your camera, that would be great because then I can see you. Okay, so we also have the composition and modularization. And this is very important when you are more experienced software developer. So when you are an intermediate or senior Java developer, you have to have the skill of breaking problems into smaller testable units. So for example, if your manager gives you a big story that is a microservice that's very complex, you have to have the skill of analyzing the story, breaking it down into different stories, right? Well, usually when we build story in Scrum, we call it as epic. So we have this epic, which is a huge task. If you don't know the terms of Scrum, I'm pretty much sure you know the terms of Scrum, right? So story is basically a task that has 8 points of complexity, something around 8 to 13 points of complexity. And basically, when you get an epic is basically the big picture of a big problem. And then you have, as a senior or intermediate developer, you have to have this mindset of knowing how to break those problems into smaller parts so that you can solve those problems and you can organize your work. And the other thing is to know how to design cohesive and loosely coupled components. And I see many senior developers doing horrible things in the code, and that's not good. We should always strive to create our code in a way that it is maintainable and in a way that other developers can understand our code. So sometimes using the right design pattern is a good thing, but obviously overuse design pattern when it's not necessary, it's a waste because it will only make the code more complicated. We have to keep that in mind and thinking patterns. So when we are working in any kind of programming language, we have to try using the design patterns from AL4, or you have to use the solid principles. Also the principle of don't repeat yourself and keep it simple. So those principles are very important. And when I say those principles are basically the principle of breaking down your classes. So if you have a specific domain, create this service that will handle only one part of the business. Don't put everything together. Any class you can break it down, just do it, because then you can reuse this class a lot easier in your application. And when we are writing code, we're not writing code for ourselves. We are writing code for other developers. And understand more about concurrency. So learn more about the producer-consumer pattern, like message brokers. Learn more about thread pools. So those are important coding principles to make you a better software engineer. And for Java-specific expertise, you don't need to be a specialist in the JVM, but it definitely helps. Even more for business applications, you wouldn't be dealing directly with memory management or bytecode, but still it's good to know at least the basics. And it's important to understand what are the most important features from the Java programming language, like streams, lambdas, optional records. You also have a very robust concurrency API in Java. You have many concepts that are essential, like error handling, or the wrappers, or like how you handle object-oriented programming with Java when you use inheritance, when you use polymorphism, or when you use composition. All of those things make a difference when you are developing your application. And also think of ways to make your code as immutable as possible. Because the more immutable your code is, the less chances of having to handle bugs, having to fix bugs. It doesn't mean that your code has to be fully immutable. Like if you wanted that, you could use a functional programming language like Clojure, but that's not the case with Java. Java, we have a kind of a mix of object-oriented programming with functional programming. But anyway, try to make your code as immutable as possible. For example, you could use records, because in records, you can't change the state of the variables in your record. So this could be a way to make your code more immutable. And also understand the specifics of concurrency and parallelism with Java. So understand thread safety, synchronized locks, the volatile word, when you would use completable future, fork join pool. Reactive programming, you don't use it very much in Java, but it's still good to know at least the basics. Because, for example, you use a lot of reactive programming when you are programming with Angular or any front-end application, you would be using reactive programming. But it's in Java, it's not that likely that you would be using reactive programming concepts. The third topic here is about debugging and optimization. So nowadays with microservices, like we have to read more and more those logs on applications such as Datadog or Prometheus and Grafana. So nowadays it's more complicated to debug code. With microservices, we have to read the logs of many services. You have to track it down. So it's not as simple as it was with Monolith. So it's more complex, and we can use, for example, Visual VM, JProfile, Async Profiler, and like we don't use those very often, but well, sometimes we have to identify where is the bottleneck of our application. And to do that, sometimes we're going to have to debug it manually. Like sometimes we're going to have to create specific conditions in our logging application. So to identify bottleneck problems, like maybe a stress test in the API would help you identify that, but it's not that easy. Like maybe a testing with Gatling. Gatling is a very good way to automate your tests and send 1,000 requests to your API to check what is the bottleneck. So using Gatling could be an option. So I will even write it here, Gatling. And caching strategies make your microservices a lot faster, a lot more performant. So we can have a look at Guava, Caffeine, Redis. Redis is very likely the most popular tool for cache. And if you know that certain information will not change from the backend, you can use cache, and then you will improve performance of your microservices very well. And when you are solving a bug, and I see many senior developers, unfortunately, solving bugs in the wrong way. So they basically use the golden hammer, right? So what is the golden hammer? The golden hammer is basically when the developer doesn't care about code quality and the developer only cares about solving the bug. But the problem is that when you use the golden hammer, you are not solving the bug from the root cause. So just solving the small issue. But then when you are focusing on the small issue, what happens? Usually the problems around this thing, like you're going to create more problems. So it's better to analyze what's the root cause of this bug. So sometimes there will be more work, yeah. But I assure you that if you solve the root cause issue of the bug, you're going to have a lot less of a work. And one way to help you find what is the root cause of the bug is by reproducing those issues in isolated environments. So if you have a sandbox environment where you can test whatever you want, then just do it, right? Because if you solve the root cause of the bug, you won't have to solve this bug again. And if you only use the golden hammer, like then it's very likely that you're going to solve this bug, but you're going to have other bugs. Other bugs will show up. So like this won't be good. The other principle is to think about code quality and maintainability. So it's very important to use clean code practices. And when I talk about clean code practices, it's simple things like meaningful naming, small methods, single responsibility. So if you're creating a class, use a meaningful name, use a class that makes sense for the business. Methods, I've seen even principal software developers creating methods with more than 1,000 lines of code. It was horrible. I know they were under pressure, but still this is really bad. I had to create 1,000 lines in one method. I don't like that. And preferably like write small methods, break them down, create methods where their domains make sense. For example, if you have a method about payment, don't create this method of payment in a class that is accountant. Like that has nothing to do. And also avoid anti-patterns like God classes or spaghetti code. Like I see this many times, like in applications. So what is a God class? A God class is a class that has every responsibility you can imagine. So we have to avoid those kind of classes. And spaghetti code is when you see 5,000 lines of code in one method, which is horrible. Like how can you even create unit tests for that? So a good way to know if your code is good or not is if you're able to create unit tests easily. Like if you can create unit tests and you don't have much of a trouble, then the code is good. Otherwise, the code sucks. So, and also like this is even more important when you're using microservices, use integration tests, end-to-end tests, because, unit tests is good because it helps you to get small bugs. And it also helps to see if your code is good or not. But usually, like to find bugs more quickly, use integration tests or end-to-end tests. So common tools for integration tests are rest assured. End-to-end tests is also very common to see Selenium. So in your application, the company you're working for, like if they are not using end-to-end tests technologies or integration test technologies, there's something wrong. You have to tell them, hey, we need to use those. And it's also important to know about Mockito, WireMock, and test containers so that you create, robust tests for your code. And then you are able to create good code with that. And there's also refactoring legacy code techniques. So when you have bad code, and that's very common for many Java developers, I know they have this issue in their companies because maybe they are working for big financial companies, and you have to adopt a strategy to improve the code quality. And to do so, you need to talk with people, right? Because only you won't be able to improve code quality yourself. So you're going to have to basically work on the culture of the company, talk to your boss, and, influence people to adopt a good mindset to improve code quality. And how can you do that? By talking with people. Only you alone, you won't be able to improve bad code, to improve a bad project yourself. And if you join a company and if you see bad code and you start pointing fingers to people, what's going to happen is that people will hate you and you won't be able to help them, right? Because you can only change big things like that only by influencing people, right? And guys, if you can turn on your camera, that would be great because then I can see you here. I have all of you here on yeah, that's great. That's good. So yeah, only Mehmet turned on his camera. Come on, guys. Turn on your cameras. Okay, Ron's turning on. Oh, not yet. Not yet. Grace, Moad. Okay, that's fine. Okay, guys, but I like to see you. Otherwise, it seems that I'm talking to no one. Okay, that's great. So yeah, guys, I'm pretty much sure you've been through situations where it's horrible, where the code really sucks. And like I've seen many developers being really frustrated to see bad code and they don't do anything. Usually they just complain, but that's not the way to solve the problem. And unfortunately, it's very difficult to solve the problem because it's a cultural problem, which means that the only way to improve the code is by talking with people and influencing people. You can't impose and say, hey, you all suck here. I am the best and my code is better than yours, and change everything because you are useless. You can't do that, right? You have to influence people and not to be arrogant thinking that you're the best. Instead, it's better to have the approach of being humble and trying to understand the context. Say, hey, okay, maybe they had the parts deadline. Maybe they lack knowledge to create good code. Maybe, I don't know, could be any reason, but don't judge people thinking that you are the best. Because if you go with this mindset that you are the best, it's a trap because then you put your ego in control, which means, and you also put everyone against you. So the best approach in this case is to talk with people, be nice with people, and just tell them, hey, just tell them some ideas to improve the code. Maybe you can use some Asana rules. Maybe you can refactor some small bits of the code, or you can create a component that will remove all the code repetition. Not all the code repetition, but a lot of code repetition. Sometimes you see a lot of copy and paste, but if you think about a component, maybe you can create a small library, a small lib that you can reuse code. And then you can present to your team, and then you can influence them to also do the same from what you're doing. right? And then you make other developers more productive. You show the value of that. But the worst thing you can do is to say, hey, your code sucks. I'm the best. And I will change everything. Because if you do that, you're going to have the contrary. Like people will hate you and people, they won't be waiting to change. They will be only saying, hey, I hate this guy. Let's fire him or her. So yeah, so pay attention on that. And nowadays, so with microservices, this is even more important, which is system design and scalability. So, and nowadays we have this interview and it's very common. It's very popular, right? So if you go to any interview as a software developer, you're going to face the same kind of test, which is the system design interview. And sometimes you're going to have to design Instagram in 45 minutes, or you have to design like Discord or whatever the application. And it's important to develop this high level design thinking. So you have to think about the trade-offs in architecture. So if you're working in the microservice architecture, and it's very likely, so who here works with microservices? They just say yes. I think everyone probably. It's very rare that, yeah, João is working with microservices. Who else? It's very rare that developers are not working with microservices nowadays. Monolith it's not that it's a bad architecture. It works, right? But most companies, they don't want to be with microservices, maybe because the big techs want that and because, developers want to work with microservices as well. So monoliths are great. If you are creating a small project, go for a monolith. Break it down into modules, then you break it down into microservices. Like you don't need to create right away a microservice. Because actually, the fundamentals behind the scene of a microservice is that you create a modular project. And obviously, like the deployments of each microservice, they are independent. And you can create microservices even with different programming languages. Anyway, you know that. But, in an interview, it's important to know the trade-offs. So if the interviewer asks you, oh, what's the trade-off of using monolith versus microservices? You have to know that. You have to know that microservices are more complex. Monoliths are simpler. But if you want to scale your application, like forget it. You can't use monolith. Imagine deploying the elephant of Netflix with a monolith. It would take, I don't know, like 1 day to deploy the whole thing in a monolith. Would be ridiculously complex. Imagine if there is a bug and you have to solve, then you solve a bug, then you have to wait 1 day to deploy the whole application. Doesn't make any sense. Well, that's why like in Netflix, in huge teams, it makes sense to use microservices because then you can break it down to smaller services and you can have teams that are responsible for each microservice and they have the ownership of those microservices. So you can communicate between microservices and that's perfect. That works very well in big companies. And Capterium, so this is very useful to know, to understand what database you're going to use for your microservice. And there is even a book that's very good. It's Data Intensive Applications. And I highly recommend you to read this book because this book really helps you to have a mindset of how you can create highly scalable microservices. And this also helps you a lot on the system design interviews. So this is a very good book. I'm going to put it here. Java ecosystem best practices. So nowadays, the most used framework in the world for Java is Spring. But really, if you know the main concepts of Spring, like dependency injection or AOP or configuration, it's going to be pretty much the same for Quarkus or Micronaut or Jakarta. So if you know the principles of those frameworks, you are doing fine already. But I recommend you, if you're looking for jobs, the most important framework is Spring because the default stack of the market is pretty much Java, Spring, and AWS. So if you know this stack, you are good on the back end. Front ends, there are still some opportunities, but as a Java developer, those tools are more valued. Understand more about database interactions with JPA, Hibernate, query optimization. Those skills are very important because most of the projects we're going to be dealing with database operations and resilience and fault tolerance. We know that with microservices, there will be fault and sometimes it won't work. Sometimes the service will go down. And that's why you have to think about resilience like microservices, it's very important to have circuit breakers, retries, bulkheads, and we have to also sometimes handle back pressure. But the most used patterns that we're going to be like more often using is retry, circuit breakers, and that will already help. And timeouts, like use timeouts, like when you're invoking one API and you don't know, like sometimes that there might be a fault, like use a timeout when you're doing HTTP request. And also I recommend reading this book, Data Intensive Applications. Okay, then, so we also have to adopt the mindset of continuous learning because in our area, technologies are always evolving. So it's important to be studying, to be up to date technologies. So for example, the Java vendors, they are releasing a new Java version every 6 months. And Java 25 is about to be released, which will be another LTS version. If you don't know what's LTS, it's long-term support version, which means that Oracle or other Java vendors like Azul, they will be supporting the Java programming language for longer, which means that it's a good version to use in production. And, you have to follow up with those features like record sealed classes, virtual threads. Virtual threads is a big one. And this is really important because it makes your services more performant. And it's good also to be familiar with tools like GraalVM or Project Loom. So basically, it's important to be aware of the new Java releases, versions. And every time there is a new Java version being released, there's also lots of videos on the internet. There is lots of articles, and it's pretty much easy to understand what are those new features. You don't need to be a specialist in all of those Java versions, but it's good to know what is new. So for example, if you never tried virtual threads or sealed classes or records, just take some time to do it because then you can potentially use it in your project. Also, like when you're working with junior developers, mentor them, help them. I'm not saying that you should let them take advantage of you. Like you have to be careful. Like obviously, if there is a junior developer who is lazy, who is not doing their work, then you say, okay, I won't be wasting my time here. Like there was those kind of situations in previous jobs of mine. Like there was a developer who wanted all the answers. And I used to tell him, hey, this book is very good. Can you do that? Can you read this book? And it passed 1 month, 2 months, 3 months, and he never read a book. He never tried to do anything. So like when I say here to be a mentor of other developers, obviously you mentor developers who are committed, like developers who are lazy, who don't want to grow, who are there just draining your energy for nothing. Then like you just understand, okay, like you can't let people take advantage of you. Basically, that's the point. And on the other hand, it's important to be a mentor of less experienced developers because you're going to improve your communication skills. And the more you help less experienced developers, the better you get in your leadership skills. And people will respect you more. Obviously, if you're being taken advantage of, then there's no respect. People will disrespect you. But if you see that, okay, this guy or this lady is, they are making an effort, they are, doing their part, then it's a good person to mentor, right? And do pair programming, knowledge sharing. Like if you can do that with people in your team, definitely that's a good thing to do. Community engagement. So if you have a Java user group close to your place, like I don't know where are you guys from, like if you can tell me what countries you're from, and if you can tell me if you go to Java user groups or not, because that's something important. Like to go to Java user groups, meet new developers, understand how is the market. Those are actions that will help you to stay ahead in the game. Because if you don't go to conferences, you don't know what technologies are the new ones, what technologies are relevant, what concepts are relevant. So it's important to join a Java user group close to you. If you don't have any Java user group, consider creating one or participate in virtual jugs. For example, there is Ali. Ali has a virtual jug in Riyadh, Saudi Arabia, and he's hosting many Java developers there. There are many talks that are great there, and you can just join this WZ group and watch all of those great talks. So I can even share with you here. If I find here Riyadh, just a moment. Yeah, found it. So I will share here with you. So I'm gonna put here in the mind map. And guys, if you stay until the end of this live, I will be sharing with you this mind map. So basically there will be a form of satisfaction of this live. Then you can tell me your career challenges, what you liked from this live, what you didn't like. And then I can improve. The more I get feedback from you, I can improve. But you can basically access Riyadh Jug. I highly recommend. Adi is a good friend of mine and he's doing a great job here. So we also have to balance idealism and practicality. So sometimes we want to improve all the technical depth. And I know it's a constant battle between developers and business, because developers, unfortunately, we like to neglect soft skills development, and sometimes we suck in our communication skills. But we have to make an effort, constant effort, to improve our communication skills to be able to discuss high-level topics with business. Otherwise, how can you prove that working on technical depth will help, for example, the company have more profits, or will help developers to be more productive? So sometimes, like, we have to also balance, right? Because sometimes we want too much. Sometimes we want to do like a huge refactoring the code, but sometimes it's not possible. Sometimes, we need to deliver business features. Sometimes there's higher priorities, and discussing those priorities with business is a very important skill to have. Otherwise, the software will be always solving bugs, and life will be a lot more difficult as a software developer. So, and sometimes it's not worth it to over-engineer solutions. Sometimes, we just need to prove that something works, and you create an MVP, minimal viable product. So sometimes you just need to create something like a POC. Create a POC, see if your solution works or not. You don't need to create very robust solutions sometimes. And you always have to balance that depth with business needs. Sometimes, like I said, you can't impose and say, hey, business, let's refactor off this code because this code is useless. This code is very bad. Sometimes you have to know how to tell them, how to influence them. And if you're not capable of showing the value to them, they're going to put you off. They're going to say, hey, no, that doesn't work because we need to deliver higher priority tasks. So be aware of that. And talking about risk management. So when you're using Maven, for example, we sometimes are going to use lots of libraries that might have a security vulnerability. And, sometimes if you go to Maven Central, you can check, you can notice if there is security vulnerability there. And there's even tools like Sneak. With Sneak, you can check, it makes the analysis of your code, and then it checks if your dependencies are vulnerable or not. And it's also important to learn more about OWASP, security considerations, because sometimes, you might have a very silly error in your code, you might have vulnerability for SQL injection, or, any kind of vulnerability. And there are some tools in the market where you can identify those vulnerabilities in your code. So it's good to learn about OWASP. And I remember when I was working for Equifax in Dublin, we were using an HP Fortify tool, and we were scanning the whole code to check OWASP vulnerabilities. And, for fintech, for financial applications, this is even more important, to know about security. And that's an area that will grow so much. It's still an area that pays so much. And it's definitely something worth it to focus on. If you above the senior position, if you want to earn a lot of money and say, hey, I want to earn a lot of money, I will become a specialist in security. Then they're going to earn lots of money, because when you are a senior developer, there isn't much more to do. But when you are a specialist, the companies will pay a lot of money for you to solve their security problem. Imagine Equifax, when the breach happened, they lost $500 million, almost $1 billion. If they paid you at least $3 million, it's, a very good amount of money, and it would solve their problem. They would, save like more than $400 million. So that's why they pay a lot for security specialists. So, and that's something important. Like even if you're a Java developer who doesn't want to be a specialist in security, it's also important to know about OWASP. And another mindset that I used to have, and it's not so good, is to have the mindset of Java developer. And it's much better to be a software engineer who knows more than one programming language. So if you're studying for the algorithms test that I know it sucks, but try to use another programming language to at least learn another programming language. So, I don't know, it's fun. So what are the benefits of learning more than one programming language, more than Java, for example? Because then you can choose the right tool for the problem. So for example, for Python is excellent for scripting or for data science. Go is very good for concurrency. So if you think about it, the Kubernetes tool was entirely created in Golang. Golang is an excellent programming language as well. And the other thing, another mindset that's important to have is that, for example, if you know the paradigms of a programming language, like in Java, if you know the paradigms of object-oriented programming, if you know the paradigms of error handling, if you know the paradigm of functional programming, the paradigm of algorithms, like if you know all of those fundamentals, going to another programming language is not that difficult because in most of the times, it's just a matter of learning the syntax. So don't have this mindset, oh, it's another programming language, I can't do it. You can definitely do it because you're a Java developer, right? To migrate from Java to Python, it's a lot easier. To migrate from Java to C#, it's a lot easier as well. To migrate from Java to C++ is not that easy because C++, you are dealing with a low-level programming, like you're going to be dealing with pointers. So this is another paradigm. But, if you're working with programming languages that have the same paradigms of Java, it's going to be a lot easier, right? So if you have a good job position that requires you to know about Golang, Kotlin, or Scala, it's a bit different because it's a fully functional programming language. So the learning curve will be a little bit steeper. But for programming languages that are like Python, C#, Golang, like it's going to be easy. So don't worry about that. Like I said, avoid language lock-in because then you can expand your career opportunities. Obviously, we love Java, but doesn't mean that we can only work with one programming language. We can work with other programming languages as well. And so Java excels in enterprise applications. So we can create really robust applications like Netflix, like most of their microservices they are using Java. And other programming languages might be better for data science, low latency systems like Python or Golang. And there are also the cross-language concepts patterns. So for example, concurrency will be the same for every programming language. Like you have Java threads, executors. In Golang, we have Go routines, Elixir, Bing, VM, memory management. Like we have the garbage collector in Java. We have in Rust, it's manual, like C++ or C. And we have reference counting, Python, but they are similar fundamentals. For error handling, we have exceptions in Java, result types in Rust or Kotlin, or we have also let it crash in Elixir. But those are very similar concepts. We have metaprogramming. So in Java, we have annotations, we have macros in Rust or Clojure, or decorators in Python. So you see, they are doing the same thing with different names. And you have the paradigms of OOP, functional programming, algorithms. So if you open many of the classes on Java, you're going to see the same algorithms you would see in any programming language. So you're going to see graph, you're going to see arrays, you're going to see how like a linked list behind the scenes is a graph, for example. So if you open those collection classes, you're going to see all of those algorithms. Like if you, for example, open the sort method from collections.sort, you're going to notice that the sort method actually is the algorithm of quicksort. So if you open the Java code from the JDK, you're going to notice that it's basically the same from any programming language, like always the same fundamentals. Like you're going to see lots of algorithms inside there and lots of design patterns. You're going to see, for example, the builder pattern, you're going to see a lot in Java, the factory method, you're going to see like sometimes template method. So And the factory method you can see in the JDBC library. Anyways, not only those design patterns, but you can see lots of design patterns in the JDK code. You can even ask to AI, give me an example in the JDK code about the builder pattern. Can you give me some examples? You're going to see lots of examples. Or, the strategy pattern. The strategy pattern you can see with the run method from threads. So if you instantiate a thread and if you execute the code like from a behavior for this run method, this is a strategy pattern. So there are lots of design patterns that you can see, not only on the JDK, but on Spring as well. So basically, guys, it's important to have the mindset of a software engineer and not of a programmer anymore, because nowadays it's impossible to learn lots of technologies. Instead, we have to learn enough to be able to solve problems. Because if you try to learn everything, like you're going to spend, I don't know, maybe only to learn AWS, you would take, 5 years to learn everything. It would take many years. So instead of learning the whole thing, like separate, you can even use the just-in-time learning technique. So for example, if you have something in your job that you never seen before, like once you get that problem, then you study. You don't need to study the whole thing because that's impossible. Actually, one of the most important skills for software engineers is the ability to learn things faster. So if you're able to learn things and if you're able to think like a software engineer, as like a software engineer who is curious about new technologies and about how to handle issues you will have on your day-to-day job, the better. You become a better software engineer. Like faster learners are nowadays one of the most important skills of software developers. Okay, guys, so that's pretty much it for today. So let me just recap here. So we talked about core solving problem techniques. So it's important to create maintainable code, reusable code. It's important to know about Java specific features, debugging. When you are solving a bug, solve the bug from the root cause. And always think about good names for your code, testing strategies, refactoring techniques, and use techniques to scale your microservices. Use design patterns to help your microservice be more resilient. Never stop learning because in our area, things evolve so fast. So stay up to date, elaborate some schedule that works for you to be always learning, participate in a Java group, mentor less experienced developers, and don't let people take advantage from you. Also balance the technical side and the business and learn more than one programming language. That will make you a much better software engineer. So that's it, guys. I hope you liked this live session. I'll be here the other Tuesday at 10 p.m. London time. And that's it, guys. Thank you so much. And I hope you have a great week ahead of you. Okay? So I'll see you later then. Thank you so much.